Good morning to everyone. Thank you very much for joining us today. I'm Evelina Parisi from PISTACHIO, and today Giulia Rosar, that is Senior Product Manager always in PISTACHIO, will present today a novel solvent-free analytical solution for the analysis of total aflatoxins. The webinar will start soon with an introduction on aflatoxins risk assessment and regulations, the presentation of the novel ELISA test kit H2AFLA, the available assay formats, the features, and some highlights over the validation of the system on different matrices. During the whole session, you will be muted, but you can drop your questions in the chat box, so we can have a question and answer session at the end of the speech. Giulia, please, you can start your communication.
Good morning, Evelina. Thank you very much for your support and welcome everybody to the webinar. I'm entering immediately on the core of the presentation. Thank you a lot for this short description. So let me spend a few words on aflatoxins contamination in food. As you all know, I'm sure, aflatoxins are mycotoxins produced by two species of Aspergillus, that is fungus found especially in areas with hot and humid climates. But it must be noticed that also drought can enhance aflatoxins production on some vegetal commodities, as the lack of water itself is stressful for plants, and it could turn into a reduction of their capacity to defend themselves against molds. According to the European Food Safety Authority, aflatoxins can occur in many different foods, such as you see here the list: the groundnuts, tree nuts, maize, rice, figs and other dried foods, spices, crude vegetable oils, and cocoa beans as a result of fungal contamination before and also after harvest. Several types of aflatoxins are produced naturally. Among these, the most common is aflatoxin B1, that is also among the most potent genotoxic and carcinogenic aflatoxins. And aflatoxin M1 is its major metabolite in humans and animals, and it can be present in milk from animals fed with aflatoxin B1 contaminated feed. So you see that the risk of exposure for human beings to aflatoxins is multiple, both direct through the consumption of vegetals that have been contaminated and also through animal products like milk with aflatoxin M1 in it. As anyway, not just aflatoxin B1, but also all aflatoxins are known to be or genotoxic, either cancerogenic. Exposure through food of any type should be kept as low as possible, or as European Union say, as low as reasonable achievable. Their presence nevertheless has been reported worldwide, with severe outbreaks registered in different regions from year to year. And as a logical consequence, both the European Union and also the Food and Drug Administration have set different action levels for aflatoxins in general, not just for B1, and several food. And we are now entering on the discussion of these limits and their presentation. You will see that there will be two different logics on the basis of different legislation. So I'm very sorry for this very huge table. The European Union chose to set two separate limits. One for aflatoxin B1 only, that is indeed the most abundant, and one for total aflatoxins. One concentrations or maximum limits mentioned this name total, which aflatoxins do we refer to, as many different metabolites exist. This refers to the sum of aflatoxin B1, B2, G1, and G2. Again, let me underline once more, the most frequently found aflatoxin and contaminated food materials is the B1. It is also the most dangerous. And the three others are generally not reported in absence of aflatoxin B1. And this huge table, I did not report the limits for aflatoxin M1, but also are in place for milk and dairy products. So you can now see just the limits for native aflatoxins in foods and commodities of vegetal origin. Most of the limits that have been fixed for the total aflatoxins are, let's say, double time the permitted concentration of B1 only, with a few exceptions where this proportion is not 100% kept, like the case of dried figs and almonds, and also some groundnuts, and feed materials where total aflatoxins limits have not been set. By an analytical point of view, being the aflatoxin B1 the most occurring and abundant aflatoxin form, often it has been considered that the concentration is, 10 times higher than each of the other forms. Many food chains have actually adopted analytical routines for aflatoxin B1 only, with the assumption that a compliant result for aflatoxin B1 will surely be a compliant, will surely mean a compliancy for the limit of total aflatoxins. And this assumption is pretty good, but nevertheless, it must be noticed that the natural proportion among B and G aflatoxins is not strictly fixed. And the different patterns could be affected by many reasons, like the origin of the food material, the climate, the fungal pattern, the type of the variety of the crop, and so on. So G1, for instance, could have also relevant concentration indeed, that could be a product that is maybe limitedly compliant to the B1 to be non-conform to the total aflatoxins 1. Otherwise, we wouldn't see the reason to have this list of two limitations. And just to reinforce this concept before concluding this discussion over the European legislation, one of the most famous, I would say, important proficiency test and control material provider that is known, that is FAPAS, offers samples with different food contaminated with aflatoxins as different ratios, so not just with B1 and traces of the rest. Sometimes they put G1 as abundant as B1, or G1 equal to B2 and G2 and relevant concentration. And this is done indeed to challenge the methods, the analytical methods for all aflatoxins to determine all the forms despite their natural proportion in routine samples. So the point is we cannot stay 100% confident that B1 is sufficient and is the only parameter to have analyzed. If we have a look to the FDA compliance policy guide, we see a shorter list of products and the differentiation in terms of type of products. Higher levels are admitted rather than the European Union, and these limits are always expressed in terms of total aflatoxins. So outside the European Union, it is considered that total aflatoxins together, despite their natural occurrence and natural proportion, must stay below a certain level. I can add as a unique exception that China has adopted a specific regulation for aflatoxin B1 only. As for the rest, you see the importance of monitoring the total contamination of products. So our goal as Eurofins Technologies as a global supplier of solutions for the analysis of chemical contaminant and different matrices was to develop something that was fast, sensitive, and accurate with a consistent capacity of detecting all aflatoxins. And here we are entering the very core of this presentation. H2AFLA as a novel rapid enzyme immunoassay plate-based kit developed by our researchers in Italy using a broad range antibody that covers all the 4 aflatoxins 4 with really relevant consistent cross-reactivity. This kit also embraces the green fingerprint of Eurofins and removes the solvent from the sample preparation and assay implementation. The sample is indeed extracted with an aqueous solution that is prepared by diluting a buffer and some powder salts that are provided in the kit. So you just have to add the water. Then once you get the dilution buffer that is ready to use, it is stable for a pretty long time and can be stored for routine analysis. The solution that you obtain is fully non-toxic, non-harmful, and can be used definitely outside a fume hood. Same for calibrators also that are included in the kit. They do not contain any solvent as well. The sample preparation, despite the fact that aflatoxins are not hydrophilic, has been kept very simple and fast. Once the extraction solution is ready, it's diluted, it is sufficient to add it to the sample following the prescription of the kit insert. You have to shake a few minutes and filter. So it is exactly a regular sample preparation of those common kits based on methanol water extraction. You don't need centrifugation, any syringe purification, column purification. It's very simple and very fast. The assay also is very short. It is as short as 10 minutes. There are 2 incubations of 5 minutes each. So during the first one, there is the competition between the aflatoxins contained in the samples and the aflatoxin B1 conjugate to that is conjugated to an enzyme. They compete for the binding site of the antibody that has been coated to the plate. Then a washing step removes any unbound material. And then there is the second incubation. You have to add a colorless substrate so that the enzyme conjugate that has remained coupled to the solid phase, it can convert the solution that is colorless at the beginning into a blue product. And the color intensity will be proportional to the quantity of conjugate that has been remained captured by the antibody on the plate. And this means that it is inversely proportional to the concentration of aflatoxins in the sample. After stopping the reaction with an acid solution that is obviously provided in the kit, the results are acquired through any kind of photometer equipped with a filter at 450 nanometers. And then you can easily calculate your results with our Excel spreadsheet that you can download from Eurofins Technologies website. The kit allows quantitative analysis of total aflatoxins and the range from 2.5 to 50 ppb. But we have seen a relevant difference in terms of legislation between Europe and the rest of the world through the FDA compliance policy guide, so you can expand or extend the measuring range by diluting your extract, and you can move your measuring dynamic range up to 500 ppb. Before we move on with H2AFLA, I want to mention this solution. So based on exactly the same reagents and the assay layout, the researchers successfully developed one cost-efficient version of H2AFLA that is based on the removal of physical calibrators. You know that standard solutions are usually necessary in each ELISA analysis to guarantee quantitative accurate results for samples. As the environment and human execution have a role, a very important role, in the signal relative intensities and therefore can affect results, calibrators are run together with samples to match any systematic data shift. So just to make my point very clear and very easy, if the assay is incubated, for instance, I don't know, at a warmer temperature, both samples and curve will. If the incubations are extended for any reason, like a mistake or some interruption to the analyst, well, again, both the samples and curve will. And the curve has also an important role as it allows analysts to check the session compliancy. But the point is, what if the assay is robust enough to permit the dosage directly on a virtual curve with comparable quality? One single standard will be sufficient to align with environmental conditions. As a result, the removal of physical standards bring an important improvement in cost efficiency. The number of wells spent per session is equal to the number of samples that you have to analyze in that very session plus 1. And this means that the whole content of the kit can be used for a bigger number of samples. That means that you really use the kit for real analysis. This is actually a little benefit when you have a very huge analytical volume in routine. If you're able to merge a lot of samples in one single session, okay, the cost of calibrators is pretty irrelevant. But if a laboratory or an industry needs, I don't know, to run averagely 3 samples as it is reported here in the scheme on the right side of the slide. So if you run averagely 3 samples per session with a regular kit, you will use 8 wells every time. That means that you will be able to use one kit 12 times only, and you will use the kit for 36 samples. With a virtual master curve calibrated assay, you will spend for each session 4 wells only, 1 for the 0 standard and 1 for each of your samples. You can exploit the plate 24 sessions and run 72 samples. So the reduction of cost is easy to calculate, is 50% of the kits cost the same at the beginning. It is important, so in my vision, to keep in mind this very valuable option for each little analytical volumes. The B0 H2AFLA shares the same reagents, features, and almost the same validation of the regular H2AFLA. And it tends to be a very low cost option for industries and for small laboratories. It can be accredited, it can be validated, and for having more confidence in the result, it is always possible to include a reference material, a control sample in the routine analysis to check not just the assay, but also the sample extraction, if it works, if it is satisfactory or not. So it is really a valuable option for low-cost analysis. So let's go back to the features of H2AFLA that once more are in common with the B0 format, the master curve calibrated assay. I started the presentation underlying the importance of identifying a binding system, an antibody, with consistent capacity in detecting the 4 main aflatoxins. There are some products that are commercially available that claim to be intended for the analysis of total aflatoxins, but indeed they have good cross-reactivity for aflatoxin B1, and then they have less than, I don't know, 50% cross-reactivity towards the rest of the forms. And this means that the kit is going to be accurate when B1 only, or the predominance of the contamination will be due to aflatoxin B1, but they are going to be underestimating if the sample is for any reason contaminated with the 4 toxins. In this graph, you see the mean validation curve of aflatoxin B1, that is in this graph in blue, and as the mean inhibition obtained by 6 independent sessions that has been overlaid with the mean inhibition curves built for aflatoxin B2, aflatoxin G1, and aflatoxin G2. The cross-reactivity was calculated as the ratio between concentrations, giving 50% inhibition. So at this very level where the dotted line is drawn. The average results are reported in the table on the right. So you see that we paid a really huge attention in selecting an antibody with cross-reactivities higher than 75% against all the aflatoxins. And this was really the key for the development of this novel immunoassay. So, as I do believe that some of you could be skeptical about the capacity of extracting the aflatoxins from matrices and commodities in absence of solvent, I have prepared some slides with some validation data. So here we start with performances on MAIZE, that is one of the most acceptable type of metrics that could be contaminated by aflatoxins. We followed the European guideline that emphasizes the importance of procuring many different blank materials for the matrix effect study, and we indeed used 20 blank materials. The lack of contamination was verified through the instrumental verification run at Eurofins Chemical Control, Eurofins laboratory in Italy. We had 3 batches of kit available and extracted each material in 2 independent sessions, so 2 times for each lot. That means that we collected in the end 120 results. We calculated the mean inhibition value at 85% and determined a prudent cutoff level at 3 ppb, considering that the curve starts with 2.5. So this means that to handle the risk of false positive results, we need to consider that blank materials, depending on their origin, protein content, and so on, could have a little matrix effect up to 3 ppb. We then investigated the assay sensitivity by spiking the same blank materials with aflatoxin B1 first, and then with a mixture of aflatoxins with keeping the B1 predominance. We detected that all determinations were above the cutoff when we spiked at 4 ppb. We confirmed then the data by preparing encouraged materials at 4 ppb with aflatoxins, this time in natural random proportion. And again, we saw that 100% determinations were above the cutoff. So here you see in the table the accuracy that we recorded for both the spiked and the encarred mixed materials, where you see there is a little overestimation that is visible due to this matrix effect. And in the graph, you see the attempts that we did to investigate the capacity of the kit of detecting also lower concentration, and then the average inhibition signal of data sets collected for PPB spiked and mixed materials. So you see a clear difference to the B over B0, the inhibition value of blank materials, and how far they are from the cutoff level. This does not mean, of course, that the assay is totally blind when 3 or 3.5 ppb of aflatoxins are contained. It does simply mean that in our hands we so little risky, let's say, to assess that to set the sensitivity at lower concentration. The value of this chapter is the fact that we really used a huge number of materials. There are some other approaches where specificity and sensitivity of an assay are set by using one single material analyzing many replicates. And despite the huge importance of intermediate reproducibility, having different materials collected through the Eurofins and Eurofins technology network worldwide really stress the assay and demonstrate which is the capacity of the kit to behave under routine conditions, let's say. We then used number of reference and control materials that we collected from different suppliers, where the trilogy are naturally encarred materials, and those from FAPAS are spiked with different quantities and proportions of aflatoxins. We wanted to investigate the accuracy and precision of the assay through the whole dynamic range. For highly contaminated materials, like the last one, obviously we applied a further dilution. You remember that you can shift the measuring range to collect the concentration also for very highly contaminated materials. Each sample was extracted 3 times and run in 3 replicates on 3 different kit batches, as we had them available. So moving away from the top of the curve, where you remember we had a little overestimation, you see that the matrix effect disappears as it normally happens with immunoassay, and results are accurate and pretty compact without significant trends or drift related to the sample concentration. Trust me, we were concerned about using water extraction for very high level contamination. 50 ppb could already be very challenging. So our question was, can we really have consistency in extracting, which is the risk of having a highly contaminated material and then finding, I don't know, 70, 60, 50% recovery for highly contaminated materials. This is definitely not the case. We see that we were able to have always good results despite the contamination of the material. And similar results were obtained, just to remind a little bit. Similar results were obtained with the B0, the assay calibrated with a virtual curve, and this was due to the good robustness of the system. So the removal of the calibration did not affect the overall accuracy of the kit. For brown rice, We had so far smaller availability of samples. We worked on 10 materials and 1 batch only, so the data set is definitely smaller. In this case, we did not notice any matrix effect. We didn't need then to set any cutoff value. For determining the sensitivity, we spiked the blank rice samples, the 10 materials, with aflatoxins, and we prepared 2 spiking solutions, starting with reference standards from Biopore, and we made mentioning 2 different spiking solutions. One had B1 as the most abundant. So you see in the first portion of this chapter, we kept the ratio where B1 was 10 times higher than B2, G1, and G2. And then we challenged the kit by adding B1 and G1 and same concentration and half concentration for B2 and G2. And what we did discover that results are totally the same. So thanks to the cross-reactivity of the assay towards the 4 aflatoxins, we got, you see, almost the same inhibition, almost same results, and the confirmation also that the limit of quantification could be set at 4 ppb as well. You see that there is a significant difference in terms of inhibition to the blank materials. All the determinations were found as positive, and the recovery, the accuracy is also pretty good. And this table, you see again the trueness assessment for 3 control materials from FAPAS and Trilogy, where each sample was extracted again 3 days and run and triplicate in each session. So we have a total amount of 9 results per material. We found a little overestimation for 1 sample at 30 ppb. We do not think it is related to the concentration, rather probably to the materials. Sometimes it happens. While the materials at 10 and 20 ppb were found to be, very accurately dosed. Peanut are among the most susceptible commodities that could be contaminated by aflatoxins. The European Union admits a maximum concentration at 15 ppb of total aflatoxins for groundnuts to be subjected to sorting or other physical treatment before consumption, and it reduced it to 4 ppb when the peanut is already intended for human direct consumption. We were able this time to collect 20 different samples of peanut of different origin. We verified that they were blank, again, through instrumental verification, analyzed them into 2 sessions and found no matrix effect. We are very happy about this result because peanut could be a challenging matrix. We didn't need then to set any cutoff. We ran spiking experiments with total aflatoxins at 4 ppb, so the lowest admitted limit in the European Union, and found that all the determinations were detected as positive. So we hadn't any false compliant result, false negative result. The mean recovery was 113%, and we had again a very good resolution from blank inhibition level. You see that the blank materials have a mean inhibition at 85 and 4 ppb spiked materials at 62% of inhibition. In the table in the bottom of the slide, you see the verification of 3 counter materials that we collected from the Italian company Test Veritas, that is proficiency test and counter material provider that uses mostly uncoated, naturally contaminated materials. These samples had all contamination level around, let's say, 20 ppb, more or less. We analyzed them in 3 sessions, 3 replicates each, and got good results with a little overestimation. That is, let's say, a prudent mistake in the sense that we are confident that we are not missing any positivity this way. For pistachio, the European regulation again allows 15 ppbs of total aflatoxins if the matrix is to be subjected to sorting or other treatment before consumption, and it reduces to 10 for the finished product when it is intended, or for direct human consumption or use as a food ingredient. For this matrix, we found the necessity of determining a cutoff at 4 ppb. We had a higher inhibition from blank materials. And then we performed the verification of the capacity of quantification at 5 ppb with spiking experiments. So 5 ppb are half of the lowest admitted level. And we were able to distinguish definitely them from the blanks, despite the fact that we had the 2 false complement results up to 40 and a mean recovery that was pretty high. But when we were able to collect one reference and card material from Test Veritas, you see in the table, the first line, at 5.5 ppb, we immediately saw the accuracy improving, the reduction of the matrix effect. And then you see that going at higher concentration, we don't suffer anymore from the matrix effect. So in this case, for this very matrix, probably the matrix is partially extracted by the water preparation, but its effect disappears when more relevant contaminations are detected. So, not to present all the data from all the matrices, just let me summarize the results that our colleagues in the R&D department have finalized. So far, it's just a preliminary list of validation. We see here just the assessment of matrix effect and sensitivity, but we have also data available in terms of trueness. And the matrices that have been investigated are wheat, sorghum, walnut, almond, copra, and soybean meal. Further matrices will be soon released to guarantee the applicability and of the kit and demonstrate the fit for purposeness of this kit for the analysis of aflatoxins in many different vegetal matrices. I would like again to reinforce that when available, we did all our effort to collect as many materials as possible to challenge and stress as much as we could our assay to detect the different materials of different origin, not just collected locally. And we performed the spiking experiments just when it was necessary at different concentration and different proportion of aflatoxins. And when possible, we used naturally incurred materials, especially those that are reference materials and control materials of qualified providers. So, conclusion: we did what we did thanks to the accuracy and precision granted by this broad range antibody. This is what I was reinforcing just a few seconds ago. The matrix effect and the sensitivity assessment were conducted using different materials, not just one. And we used both the spiking experiments and the analysis of naturally contaminated samples to enhance their variability and challenge for real the test. When no reference materials were available, obviously we didn't have for the whole list of matrices. We searched for encouraged samples, and we earlier have them analyzed by confirmation with instrumental analysis by Eurofins Chemical Control. And then we run in H2AFLA using always spiking experiments as the very last options, as obviously it simulate a contamination, but it is not true. The B0 is a low-cost version that shares almost the same performances and results, and position itself as a real cost-efficient alternative to the regular kit format. We have the performance data sheets available for both kits, and you can use them for further investigation. We will launch soon a YouTube video to show the steps of the sample preparation and analysis, and obviously we remain at your disposal for any further technical information you may need. I would like to thank you for your time today, for your attention. I was very glad to have the opportunity to present the features and benefits of this immunoassay that we've recently developed. I think I've finished. I don't know, Evelina, if we have time for questions, if you were able to collect any from the audience.
Yes, so thank you, Julia, for the very clear presentation. And yes, we have some questions, so I would like to proceed to read you some of them. First question, do you have a kit specific for aflatoxin B1 only?
Yes, we have. We have two test kits and Eurofins technologies. One is a regular kit with curve, and the other one is the virtual calibrated with the virtual curve, but they are based on regular methanol extraction actually. That has somehow a benefit because the sample preparation for both kits are in common with all the ELISAs that we have in our portfolio for the analysis of mycotoxins, done included. It means that once you have your methanolic extract in your hands, you can really easily run them onto many different ELISA test kits, and you save your time for sample preparation. And these kits are the HZAFLA B1 and the B0AFLA B1, and they are built on a very specific antibody for B1 only. So we address these kits to the Chinese people that have the legislation in place for B1 only, but also to the European companies that want to keep their routine for B1 only. Yeah.
Then there's another question. Which are the matrices are you going to test soon?
We plan to finalize the corn germ and corn gluten meal because they're really of interest. And then we plan to have, let me think, barley, pepper, coffee if feasible. It's really challenging. And then some feed-related matrices like soybean meal, DDGS, silages, peanut meal, cottonseed. We have pretty long list of matrices to investigate soon. And the audience, if there is any specific request, I recommend to reach us later with dedicated indication. And also, if you're available in providing materials and samples, you could support our validation process. We are more than happy to run the analysis in our laboratories during our own validation. So, but these are those where I know our colleagues are currently working on.
Perfect. Then there's another more technical question, I think. For washing of plates, the automatic washer can be used?
We recommend not to do so. We use an easier solution, that is the squeeze bottle. And it is a general recommendation for all our ELISA test kits. It is more powerful than the automatic washer. Don't be scared about any cross-contamination of wells. It doesn't happen. So just prepare your washing buffer, put into the squeezable bottle, and perform with your hands your washing procedure. It is more powerful and creates a real vortex inside the well. Nevertheless, we know that automatic washing is possible. Think, Evelina, that most of our ELISA test kit have been validated for being run by an automatic analyzer. So since the pipetting, including the washing and the reading. We haven't applied this very assay on a robot yet, but I do believe that with proper washing setting, it could be eventually also washed by an automatic washer.
Yes, of course. Thanks for their clarification of both the aspects. So in this case, I would like to thank all the attendees of these webinars today, this morning, and I would like to encourage also to reach us and search on our Aerofins Technologies and Aerofins Techna website. More information, and in case of other questions, please do not hesitate to contact us on our contact mails. Julia, if you would like to say hi to the attendees.
Yes, thank you a lot for your attention. We are always available for offline questions and clarification. Thank you, Evelina, for supporting, and to the colleagues in Aerofins Technologies Hungary for arranging this opportunity. Have a nice rest of the day.
Goodbye.
Bye-bye.